All right, let's continue with volume. Okay, so we have volume. This method. Okay, so just make a quick sketch. So suppose I have function. Okay, and this is the region. Where this guy's F, and this guy's G. So this is the region I'm rotating. Okay, and let's suppose I'm rotating about the x-axis. So you draw your vertical strips if everything's with respect to x. If I'm rotating about the x-axis, it has to be with respect to x. And as I draw from the top of my solid to the bottom of my solid, there is no gap between any of these red lines and the line that I'm rotating about, which is right here, okay, which happens to be the x-axis. Or it could be a line. I mean, it doesn't really matter. So since volume is the integral of area, and each cross-section is a circle, the area formula for a circle is pi r squared. So our volume is equal to, you have a pi, and we're going to do more generally, so we're going to say r of x squared dx from x1 to x2. And then here it would be top function minus bottom function is represented by this r, this radius, this vertical red distance here, squared dx, x1, x2. And in this picture specifically, it's x1, x2, and in my diagram here, it's f of x minus g of x dx. Okay, now I'm going to extend this page. Now, let's suppose, and that's for rotating about the x-axis. So I'm going to put a little asterisk there. Rotating about the x-axis, or a horizontal line. Okay, so if you want to know what that would look like, I'm rotating about a horizontal line, it's going to end up being the same thing. So let me just modify this picture here. Okay, so let's suppose I have this function f. Actually, I'm going to call this g. Okay. And then let's suppose this is f. Okay. And this is the region I'm rotating. Okay. So if you look at my vertical strips, I'm going to do these blue. And I'm rotating about this horizontal line, which is this function f. There's no gaps between these blue strips, vertical strips, and the line I'm rotating about. So that's how I know that this is a disk. And it's going to be the same thing. So I do top minus bottom. My top function is f. I want to get that vertical distance minus my bottom function, which is g. And again, if these switch, who's top and who's bottom, they have to split it up into integrals. But in this very basic example, I don't. And it's still just going to be f minus g. Oops, and I forgot to put the square here. Squared, because that represents my radius. Okay. So then if, now let's look at when my functions are in a different, okay. So let's suppose I have this, okay, and I'm rotating about the y-axis. So this is the figure that I'm rotating, and let's call, actually let's call this G, okay, and we're going to call this one F. So when I look at my, I got to do horizontal strips. Well, I'm going to do horizontal strips here. Yeah, and I have to do because I'm rotating about the y-axis. So if you notice, there's no gaps between my vertical strips and my axis rotation, so that's how I know it's a disk. And my volume is going to be pi, and it's going to be right minus left dy from y sub 1 to y sub 2. And in this one, my function on the right is f, and I'm going to write f of y minus, because this one's the one that's on the right, this is the one that's on the left, f of y minus g of y, oops, squared, dy from y sub 1 to y sub 2, and that's my volume. Okay, and this is for when I am rotating about the y-axis or a vertical line. So let me modify this picture so you could see what I'm talking about here. Okay. So let's suppose I have my picture like this. I want it to be in black. It's not black. And here's the line I'm rotating about. And let's suppose I have this function here. Okay, so I'm going to call this black line F. The red line is G. And this is the figure sandwiched between the x-axis, the red curve, and the black curve. And since I'm rotating about a vertical line, it's kind of hard to see. Draw the arrow a little bit. Then I have to do horizontal strips. And if I draw my horizontal strips through my entire solid, you can see that there's no gap between any of these green lines and this black function f that I'm rotating about. And again, so I just do the same thing. I do right minus left squared dy, pi out in the front, integral limits y sub 1 to y sub 2, and it's going to be f of y minus g of y squared. Okay, that's it.